Thank you for watching our ME351 Mechatronics and Measurement Systems Robotic Design Competition. My name is Dillon Smith. I'm a part of Group 4. I'm the team leader. And also presenting today will be Mark Boden, Jacob West, Blake Hyla, and Zeb Parsons. So I am the team lead. Blake mainly took the hardware. He was the lead hardware designer and constructor of the robot. Jacob was the main programmer. Mark was the team scribe, and Zeb coordinated a lot of the communication amongst the team members. These were not exclusive roles. We all took part in a little bit of everything, but each of us mainly took on a singular role, and these were the roles that we did.
So for our project, we decided to do a time trial race with a line following robot. We were going to do this and have our robot run trials against other robots, but being as this class is asynchronous, that was just a little too hard to complete. So we decided to do this on our own and just run times against our own robot. So we did a line following robot. That's main objective was to follow a black line across a white piece of paper and stop at a binder at the end. Now this robot would be starting behind a starting gate, which once it was removed, the robot would travel forward, follow the line the length of the course, and then stop itself at a set distance in front of the binder, which we considered our finishing gate. Now if we can go to the next slide, this just shows our robot and kind of our robot setup. As you can see, we have the battery pack up top. We have a button in there, which starts the program. So when carrying our robot back and forth, and when it's not on the course, it's not running if there's nothing that it's sensing. You can also see we have our 9-volt battery powering this, the gear motors that actually turn the wheels, and our Arduino microcontroller, which is the main controller for this robot. You'll also see in this left picture the ultrasonic distance sensor, which measures the distance from the starting gate and when to stop at the closing gate, and our line following sensors on the bottom there, which actually read the light reflection for following the black line on the white paper. Now here's a little kind of video of our robot presentation that we'll share with you now. As you can see, when that binder was moved, that was our initial starting gate. The robot does follow the line all the way through and stops at the end in front of the binder as designed.
So our design process went as follows. First, we declared pin variables and pin modes for the motors and sensors. And then we executed main code once button was pressed, get sensor or get distance readings from the ultrasonic distance sensor. While there is no obstacle immediately in front of the robot's path, it get readings from both line sensors, read values from both left and right proximity sensors. If there's an obstacle immediately in front of the robot's path, the robot would stop and flash both LEDs on and off and continue to check the distance sensor readings. If both sensors detect lighter surfaces, move all motors at the same speed, so the robot would move forward. If the right sensor detects a lighter surface and the left sensor detects a darker surface, the robot will turn right and the right LED will turn on, and then vice versa. If the right sensor detects a darker surface, then the left sensor will detect a lighter surface. The robot will turn left and turn on the left LED.
Here's a picture of our flow chart. So we start our program, and the first thing our robot will need to do is read from the ultrasonic distance sensor to determine if the gate is open or not. If it isn't open, it'll check the ultrasonic distance sensor again. If the gate is open, our robot will begin to move forward. Then we check the proximity sensors, and if the left one is dark, then the robot will need to turn left and flash the left LED. If it's not dark, then it'll check the right proximity sensor. If it is dark, it'll turn right, blink the right LED. Both of those will then loop back to check the proximity sensors again. If the right LED wasn't dark, it'll then check to see if both proximity sensors are dark. If yes, then it'll stop. If that's no, our robot will then read from the ultrasonic distance sensor again to see if the finishing gate is close. If it is, our robot will stop. If it isn't, it'll then go back and check both proximity sensors once again.
All right, so here's some pictures of the sensors and drivers that we used. We have an H bridge that was used for the speed and control variables for the motors. We have the ultrasonic distance sensor, which works as the name implies, where it sends a pulse of sound and detects the time that it takes to return the sound. And then we have our line following sensor, which is able to sense the wavelengths of light coming off of pieces of paper, and we use that for our line following. If we go to the next slide, then we can see our actuators. We used two 140 RPM hobby gear motors and then some micro servos. So if we go to the next slide, and if we were given more time with this project, we would have done further testing to decrease some of the minor issues that our robot had with following the line. And we would have incorporated more sensors and actuators to make the robot perform more tasks. And we also would have made a more complex course in order to make the competition more interesting.
And that is our Group 4 presentation. Thank you for watching.